Okay, so this is an old AP Calculus AB question. They want to know for what values of x is the function y equals 4 over 2 minus x concave downward. So in order to find the concavity of a function, you need to find its second derivative. Now when the second derivative is negative, that's going to tell you that the original function is going to be bending downward. Okay, so let's just write this function in another way. So let's write it as 4 times 2 minus x to the negative 1 power. So we could take advantage of the power rule for taking derivatives. Okay, so now let's take the first derivative of y. Okay, so we're going to multiply the negative 1 times the 4. We get negative 4 times 2 minus x. And then we're going to subtract 1 from the power. We get minus 2. And then we need to multiply by the derivative of the inside function, 2 minus x, which is negative 1. Okay. Times negative 1. Okay, and let's just simplify that. So the negative 1 times the negative 4 will give us 4 times 2 minus x to the negative 2 power. Okay, and now let's take its second derivative. So now we're going to take the derivative of y prime, which will be y double prime. Okay, again we use the power rule. The negative 2 times the 4 will give us negative 8 times 2 minus x to the negative 3 power. And again, we're going to multiply it by negative 1. Okay, and the negative 1 times the negative 8 will give us positive 8 times 2 minus x to the negative 3 power. Okay, so now let's just write this so we have a denominator, so we could better look at the actual function. So we have 8 over 2 minus x to the third power. Okay, so this is y double prime. Okay, so the second derivative, it could have a possible inflection point, which means it could have changes in concavity only when the second derivative equals 0 or if the second derivative doesn't exist. So in this problem, the second derivative is never going to equal 0 since the numerator is 8. But the second derivative will not exist when x equals 2 in this function. So let's make a chart here. Okay, so let's take values of x. Okay, so we have when x equals 2. Okay, here is when x is less than 2. And we're going to have when x is greater than 2. Let's look at y double prime. Okay, so when x is less than 2, so for example, if like x is 0, when you plug 0 into the second derivative, you're going to get 2 minus 0, which is 2, cubed, and you're going to get a positive answer. 8 over 2, 8 is 1. You get a positive answer. So the second derivative is positive, which means that the original problem y, the original function, is going to be concave up on that region. Okay? When x equals 2, the second derivative does not exist. And as well, when x, if you look at the original function, the function does not exist when x equals 2 because the denominator will give you 0. So this, the function does not exist either. Over there. Okay, when x is more than 2, like let's say 3 example, let's say you plug in 3, you're going to get 2 minus 3, which is negative 1. Raised to the third power will be a negative number. So 8 over a negative number will be negative. So whenever x is more than 2, this will come out to be a negative number. So let's write negative, which tells us the original y is going to be concave downward on that region. Okay? So an inflection point means when the concavity changes from concave up to concave down, or it could be concave down changing to concave up, but that only could occur when the function exists at that point. So if you look at the original function, The function does not exist when x equals 2. So it's not continuous at the value x equals 2. So this is not going to be, okay, x equals 2 is not an inflection point here. An inflection point. Okay, but the question is just asking when is the function going to be concave downward, so whenever x is more than 2. So let's write it as 2 to infinity. Okay, thank you.